Hi, everyone. This talk is like an experiment. It's basically just bringing some ideas that I'm thinking about a lot, and also that I'm talking with a lot of our clients, and I'm bringing it a lot just in conversations. And I wanted to bring this perspective to you. I also would probably do it a bit interactive, because that's how usually I bring these ideas. Because I think they're important, and I think it's a different perspective than maybe when a lot of people are talking about GraphQL compared to other APIs. I think it's a bit of a different perspective. So I'll try to bring it about, and we'll see how it works. I'll ask you questions, and I'll need your participation, so we'll see. A bit about me. I'm Uli. I'm the founder of the Guild. We're a group of open source developer tools and developers. We've been in the GraphQL ecosystem for many, many years. And I'll just give a brief of all the stuff that we announced in the conference, just because I have the chance to do it. The main thing is that if you saw my keynote yesterday, is that we announced a bunch of stuff that are related to Hive. Hive is basically our overall 360 GraphQL platform. So everything you need around GraphQL. It includes, a gateway. It includes a registry and monitoring tools, and also now a GraphQL caching edge CDN. And many other tools, like we announced the Hive gateway. For many years, people asked us to get to a gateway that is stable, because we kept adding more and more features to our gateway and kept changing the API. So finally, we got to that. And the two biggest things that people asked us was, first of all, stability, like a stable gateway to arrive to V1. And the second thing was to have it like basically fully compatible with Apollo Federation. So like I showed yesterday, we basically build an open source audit tool that you can run any gateway to check if if any gateway is actually fully compatible with the Apollo Federation spec. And we will use it also as part of the composite schemas working group, basically the new GraphQL Federation spec that currently at this time the panel is talking about. And we will use the same tool to also make sure that our gateways and other gateways are compatible with the future version of Federation as well. And that gateway is fully open source with all the features that you would expect from a federated gateway: subscriptions, JWT support, authorization rules, security features, and persistent documents, and many other things. So basically, it's a drop-in replacement for whatever current federated router you're using today. So that's Hive Gateway. We also basically took a bigger project that we had, was GraphQL Mesh, and split it into two. So one is the gateway that I just showed you, and the other part is basically a CLI, a composition library that takes any API. That's GraphQL Mesh. It takes any API like OpenAPI, gRPC, SOAP, and automatically converts it into a GraphQL representation, which later then you can bring in into the Hive gateway or any other gateway. So you can basically, that helps you take any API and federate it. And the other thing I showed yesterday was that we acquired Stellate. So Stellate is a GraphQL caching solution and a platform. It has many, many features, and it runs your caching on edge across, all kinds of locations all around the world using Fastly. And it also brought about an actual implementation of partial query caching. So you can send a query, and then you can basically cache just certain fields, while other fields of that query will go back to the origin. So it's a very powerful solution. A lot of people talked about it for years. Stellate actually made a really interesting implementation of it in Rust. And we now acquired it. We're integrated into Hive. And we will also open source. So you can all use the platform or just run it yourself. Yeah, so that's just like a bit of a recap of the stuff that we announced in the conference. To read all about it, just go to graphqlhive.com or come to our booth downstairs. So for this talk, I think I think I started thinking about this talk in the last year or two, when more and more people, some of them are influencers, started saying the do's and don'ts of where to use GraphQL and where not to use GraphQL. And maybe it was because we at the Guild had a lot of experience going into and working with customers that had many, many different APIs. Maybe because at the Guild we're also part of the OpenAPI Foundation, and we have a lot of experience with other APIs. And maybe it's just because I personally have a problem when people tell me not to do things. Then when people said, like, you should use GraphQL just for client server and anything else, don't do it, it triggered me. So ever since then, I had this idea. I talked with a lot of our customers about it, and I had this idea that maybe I'll just go ahead and have a talk on, why maybe the things that people tell us not to do, maybe we should do it. And I'll also add that, like, I think that I'm not the only one here that started thinking like that. I think last year the theme of the conference was like, do GraphQL this, don't do it there, and it will be fine. But two talks that I think were very interesting was one, Matt's keynote in the morning, saying that, like, we have a whole ecosystem, a much bigger ecosystem that we can improve and go into. And the second one was the talk from Firebase from Google yesterday. If you missed it, watch it online. They also are putting GraphQL in places that we shouldn't do it. And it was a really great talk on why maybe we should. But here, I told you, this is like an experimental talk. So it will be kind of interactive. So when you think about, or people ask you, if you should use GraphQL or REST or any other API protocol in certain things, comes the question of where, and there's how I see the debate on Twitter is like, is it an easy app or a hard app, or a small apps or larger apps? And I think those types of categorization is, I think, misleading because they're too broad and they're too generic. And even if you go to certain use cases, also there, in these use cases, there's all kinds of different features and things you want. Like, just the classical use cases that we can think of is like client server, service to service, data sources, and now everyone is talking about AI. So maybe the way that I look at it, and the reason my take is a bit different, which is maybe I'll say it and then you can fight me over it, is like, I think GraphQL is a superior protocol almost on any API out there. So now let's do a debate on why am I wrong. But the way I look at it is I actually look at like needs and features. So that's what I want us to do today. Like maybe I'll stop the slides in a second. I'll go to just like a random document, and I'll start asking you when we'll go use case by use case, or we go by tools, or we go by whatever is more comfortable for you to think about. We'll start talking about features of an API. What do we actually want from an API? What is an API made of? And then, we can think about we'll think about use cases and tools, and then we'll ask how does it work, and how can we make it work in each of those, in each protocol. And I'll also add another thing. I think, as we will go through that discussion, add into your minds the thing that we at the Guild are constantly dealing with, which is we can now take any API and convert it into GraphQL. And then we also have tools that take GraphQL and expose it as REST APIs. So that a bit changes also the whole discussion. Like it kind of like breaks the head of like, don't do GraphQL here and do GraphQL here, and suddenly you can interrupt all those different APIs together. Then the answer becomes even, more weird. Okay, so I think maybe let's start. So, and we'll try, I'll need your participation here. So when you think about API needs, features, and endpoints, so think about a certain endpoint or a certain project that you have today. What kind of features or things you think about from an API? I have a list of my own in case nobody will say anything, but try to come up with like features of an API endpoint or an API protocol. Yeah. Yes. Discoverability. I'll probably have a lot of like, typos, but bear with me. Oh, you're not seeing my screen at all. Okay. Let me also increase it. Cool. Yeah.
Streaming requests and responses.
Okay, streaming requests and responses. Yeah. What? Authentication. Authentication. Authorization. Yes. More features. Think about characteristics of GraphQL, characteristics of OpenAPI, or like think about why would you choose a REST endpoint instead of GraphQL, for example.
Maybe additional pagination.
Pagination. Okay. Yeah. Scaling. It's a good one. Sorry? Batching. Yeah. Link, metrics, yeah.
Type safety.
Sorry?
Type safety.
Type safety, good one. Yeah. Rate limiting. It's going well, cool, yeah. Documentation. Okay. Latency. Cool. What else? Filtering. More thing. Yeah. Request validation. Okay. So, what? Debuggability. Okay. Well, you wrote it probably bad, but okay. More things? Let me see if I have in my list stuff that. Okay, I'll add a couple of things and keep shouting more things. Okay. What? Observability. I had observability. Let's.
Incremental evolution.
Nice. So increment evolution. Yeah. Microservice architecture. What is the feature here in microservice architecture? Support. Okay, I'll ask you more about that later because I'm not sure what it actually means in terms of architecture. More things.
Monitoring and alert.
That's a good one. Okay.
Flexible. Simplicity.
Simplicity, that's a good one.
Compression.
What?
Compression.
Compression. Yeah.
Flexible data representations.
Flexible?
Data representation.
Flexible data representation. Okay. Aggregation and ordering? Nice. More? Caching. Good. More things?
Transport agnostic.
Transports. You can see my stuff, so you can copy. I'll say here schema. I'll say here, let's add real time. And I'll add one more thing, which is like stuff that are related to client. Can you can't see anymore what I'm. That just shows you that this is great because that I think already shows you like that the conversation is way more than like don't put it here and put it here. So that's already I think I accomplished my goals. But I'll say here a client. Let's put it's a GraphQL term, but like let's call it fragments. So like. How can you, let's say, associate, an API call with a certain UI component, and then let's client-side caching, which is another thing to get like instant responses and manipulations on your client side. Co-location, I'll actually name this co-location. Fetching and yeah. Okay. Okay, now you can see. There's a long list here. Okay, more things. There's more things that you can think about when it comes to API. Logging. Okay, I'll add it here also, like logging. I'm sure a lot of these things we can filter out. Keep saying more things if you have. Now, let's try another thing. Now, another thing, which is tell me by one of these features or another features that you think about. Why would you choose any other thing than GraphQL in a certain place, like and in a certain use case? And let's talk about like the places that maybe that people tell us not to use GraphQL, like interacting with the data source, like with the database, a service-to-service communication, which usually people are telling us to use other stuff. Do you have an yeah? What? File uploads.
Yeah, actually, streaming requests.
Yes.
So this doesn't work well with GraphQL.
Mm-hmm. Okay. So maybe I'll put here like use cases.
Yeah, I would like just use the REST endpoint.
Yes. Okay. Let's do service to service, and let's do data source. Okay. More like reasons why you wouldn't use GraphQL in a service-to-service communication, for example. And what would you use instead? What? gRPC? Who said? Why? Why would you use gRPC in a service-to-service communication instead of GraphQL? It's, so it's hard for me to hear. I can also bring I can pass on mics back there. So let me summarize a bit, and if not, correct me if I'm wrong on what you said. So on service-to-service communication, with gRPC, you get request compression, right? You can use a binary protocol. Oh, I think it's not working. Can you?
Hello? Can you hear me now?
Cool.
Yeah, so you're absolutely right. I think a couple of things I want to express this. The service-to-service communication, right, as we said, you can actually compress the request. There is no, you can have a binary protocol communication back on the backend side. And there is no text overhead. If you have a text, then obviously text is expensive.
Yes.
On the client side, that's required, but on the server side, that's not required.
Right. Okay. So let's start with that. That's actually a good use case that I like to talk about. So a couple of things that I would like to say. So first of all, can you think about GraphQL features that gRPC don't have that you would also want if you maintain a service that just other services are calling you?
The protocol layer that it communicates on?
Mm-hmm.
Would be one.
Yeah. Yeah.
I just want to add that gRPC is not necessarily gRPC is similar to REST, right? It's a networking layer. It's not. You don't have to use Proto, right? It can be GraphQL compatible. In fact,
Yes.
at Firebase, we actually built a gRPC server that is fully GraphQL compatible, HTTP spec compatible. So there's nothing contradicting between, hey, you cannot use gRPC and GraphQL.
Yeah, so that's a point that I also wanted to say. So first of all, GraphQL, the protocol, doesn't dictate not a transport and not the data protocol that goes. So you actually have, last year there were a couple of talks about it. You can send binary data. GraphQL doesn't tie to JSON. So you can send binary data using GraphQL. So you can use compression, you can use binary data, and still have the communication language between the two services, GraphQL. So that's one thing. So compression is a good reason to send a lot of data. I would say, so this is also possible with GraphQL. But I will also say that, so you can even you can create a GraphQL service that talks Proto. Like was mentioned before. The thing is, for me, when I look at service-to-service communication, one very important feature that people mentioned here was evolution of the schema. So let's say I maintain a service. All of us, when we use GraphQL, let's say we use something like Hive or Apollo Studio, to track the usage of our APIs. And then when we evolve, we get a new schema. First of all, we make sure if this is a breaking change or not statically, which we can still do with gRPC because it also has a schema, and we can also see if there's a breaking change. But the difference is between gRPC and GraphQL is that our consumers are querying us. They're telling us what fields they're actually using. And this is a very, very powerful thing because when they tell us what they're using, we actually get kind of analytics tools like Hive or Apollo Studio that tells us which fields people are using and which are not. And in many of the organizations that we work with, there's a lot of a lot of existing or old services. The problem is it's very hard for them to evolve and to deprecate things because they use maybe REST, maybe gRPC, like basically RPC-based endpoints. And many of them have like 100 fields endpoints, or 50 fields endpoints. For them, it's very hard to see who is using what. So deprecating and evolving a service becomes very, very hard. And with GraphQL, it's kind of like I see it as a superpower because even if a lot of services are querying me, I know what fields they're using, and I can evolve and evolve my service. This is one of, in my opinion, the most powerful thing about GraphQL. Not the efficiency of sending less data over the network, which, like you're right, on client server it makes sense sometimes. But on service to service, it's less interesting. But for service developers, knowing which fields are being used and which fields I can deprecate, this is like a superpower, especially if you're in larger companies. So that's why I always tell people, like, on service to service use case, you should maybe also think about GraphQL. And what I usually say is like, or try to do when we talk to clients is, first put GraphQL with JSON, like the regular stuff. And then when you actually need the compression, then you can also evolve into like, a binary protocol with GraphQL. But usually in most cases, the people that actually care about the compression between a service to service, like they care if it's JSON or, there's very, very few people that said, oh, it's time for us to move to a binary protocol. Like we have to do it, like the JSON between the service to service is like too close for me. So for sure it's a need, but that need can also be accomplished with GraphQL. And so I would say in that case, gRPC has a lot of benefits. Like it has a schema, like a strong schema that is very important. But GraphQL also has that. And the difference is I can query. And then I can know in the service what people are actually using. More reasons and more things to use REST over or other.
Like an analytics endpoint or something that's mostly just utilizing like a user agent header. So you typically do something like a post request or path. You're utilizing mostly headers, not necessarily a payload.
So user analytics, so like.
So you put a snippet in your header on a page, right? The user visits it, and it just sends a post request with a particular path. And that path on the server side is just like a user agent header or some other information. It wasn't necessarily mutation, but it's just a post request. There's no real response, right? It's just like an endpoint to get almost as a no-op.
I see. So you don't want to basically get, it's a one-way request. You don't want to get anything back. I see. So basically mutation without a query back. Yeah. Yeah, that's a good. So you would use just REST or something like that. Cool. I think that's completely reasonable. You could use like REST and then I think it's a good use case. I think it wouldn't require GraphQL. I would add to that what we see on the wild, like, is that one thing that for me GraphQL adds on top of many REST technologies, and you could argue that REST could do it, but on the ground not really, is the runtime validation of the schema. So that means that like it could be on the input as well, right? So let's say if you have an endpoint and you want to send something and you don't care about any response, but you want to have a validation on the input. With GraphQL, but that's true for any basically on the API. With GraphQL, we will have a runtime validation if someone started sending something wrong. With REST, we do have schemas like JSON schema, OpenAPI, all these things. The biggest problem that we see everywhere is that OpenAPI is a great spec. It's very powerful. JSON schema is like probably the most powerful schema, expressible schema out there. And in the core of GraphQL Mesh, we actually use JSON schema because it's so expressed. It's like the underlying schema that we use to convert any API to GraphQL and from GraphQL to any other thing. But all the different solutions out there are not dictating you to actually validate and check if the responses are there. And if you ask me, I would say that from our experience, seeing hundreds or thousands of companies, my very biased or very personal opinion is that 85% of the APIs out there, if not 90, are not following their own OpenAPI spec. So you could theoretically say, here's my endpoint, and here's the spec, and you should use it. But in 85 or 90% of the cases, the schema and the runtime won't be the same, and it will and people will spend so much time on it. And on the GraphQL ecosystem, it's 100% the correct schema, no matter what happens. So that's I would say also a characteristics that I would give for gRPC. But in all the rest world, it's a theoretical idea that
You're kind of describing just a poorly implemented OpenAI.
Oh yeah.
If you're using a JSON scaler in GraphQL and you just send it a bunch of garbage, it would suffer the same.
100%. So you could completely fuck up a GraphQL API, and you could completely get it right with OpenAPI. On the ground, maybe other people have other opinions. I haven't seen people. Maybe I have seen very few places where people chose JSON Scalar for their GraphQL and started doing crazy stuff there. On the OpenAPI style stuff, yeah, 85, 90%, something is wrong. But that's just on the ground. Yeah.
Okay, it's still on. What if I am a terrible developer who hasn't slept in 3 days, and I need to implement something very, very quickly? I think that might be a case for going for REST due to number of blog posts and simplicity of approaches, whereas in GraphQL, you actually have to think about how am I going to model this, or
So
what tools am I going to use?
Yeah, so you mentioned it, simplicity.
Yeah.
So I think for me, so my background, I used to be a developer on the Meteor.js framework. I don't know if anyone of you heard about it. It was all about how to, as quickly as possible, build an app. I think that somehow people told us that creating a type of something is hard. And I must say, I disagree. You're creating an endpoint, just describe. Everyone, in the JavaScript world, it used to be that TypeScript was this hard thing that nobody uses. Now TypeScript is 90% of the new code that is out there. So all you're doing is, when you're creating an endpoint, by saying what data types you're going to create, is not going to add tons of time for your endpoint creation. I disagree with that premise. I mean, I would like to see someone that is creating an endpoint and spends 20 minutes or 5 minutes just describing the model. I don't think it takes that long. I haven't. Would you agree with me, or you disagree with that?
Neutral. I haven't implemented too many GraphQL endpoints from scratch, so I don't have enough experience to draw from. What's the simplest tool you would reach for? Or maybe not simplest is the wrong word.
It's a good question, actually. So because I would agree that maybe in the past, and maybe that's why a lot of the simplicity question came to be, is that we were lacking a lot of tools in the ecosystem. There's always a need for more tools. But today, let's say on schema creation, you used to have GraphQL.js that you need to write long objects that describe the resolvers and everything. And then you had the schema first. So now you need to create a schema, and then you need to attach the resolvers. And then to connect the two, you need CodeGen, which also it's a thing that people told you it's hard, but now as the group that works on CodeGen, CodeGen now is not that hard if you use the latest versions of it. But today there's different things. If you want to create like a backend in TypeScript, for example, and there's the equivalent in other languages, you have tools like Pothos and what's the name of the other one? Gratz? Yeah, Gratz.
The implementation first ones.
Exactly. Yeah. So, first one is just, you write, with Pothos, you still write like, your TypeScript objects, and then those are describing like the schema that is going to be outputted. With Gratz is the implementation first. So you basically create TypeScript functions, and you infer the types. So there you don't even need to write, you even don't need to write types. And you get like a fully typed GraphQL server. So I don't think there's even like, and if someone would tell me that this is like taking them too long than compared to a REST endpoint, I would just want them to show me side by side and we'll see. So,
yeah, thanks.
So I'll take that into another, so we're talking about the server side, right, of the implementation where creating a schema, and it's hard, and I think, Gratz is probably, the fastest way to do it today. Like you just write a function, type in TypeScript, it infers the type, and that's your GraphQL schema. On the client side, today, this morning, Jeff's basically mentioned GraphQL Tada, right, which is doing the same on the client. So, you just connect to an endpoint, and then you just infer the types, and you get auto-completion and everything. So that also, I think, is much easier than the fast and simple process, which is sending a REST request without any types out there, or using like OpenAPI CodeGen and those tools that again rely on a schema that is 90% of the case just is wrong. So yeah, this is about simplicity. Yeah.
Bit of that, but not a lazy program, but in some domains you have specific API standards. If you're into geospatial data, you would probably go with the OGC standard for an API. It would be kind of messy.
Can you repeat? Sorry.
There will be, in some domains, there will be API standards. For example, geospatial data, you will probably go with OGC API architecture.
Yeah.
I don't see why you ever would choose GraphQL for that.
So for geospatial data, you mean?
Yeah. You have the OGC standard for that.
And then, so I'm not aware of that standard, but like, what?
I talked last year when I announced why NASA chooses GraphQL for geospatial data.
Yeah, but that's a great answer, because my guess is like, again, from building a mesh, which is a tool that takes a lot of different types of schemas and different types of data and tries to transform them into GraphQL. I would love to see this, but I have an assumption that like we can represent that we can represent these schemas also in GraphQL, and maybe I'm wrong, but like worth a try. And if you're saying you're already done it, then that's also cool.
Yeah, I mean, there are use cases. What you're describing is a standard and a specification that is specific to a domain, right? So
Yeah.
Geospatial data has OGC. There's also WMS, which is used for all the map tile stuff.
Yeah.
And then now, and the talk that I did give this year is Stack, which is the kind of newer geospatial spec. So there's specifications for all these things. But at the end of the day, the thing that organizations like us struggle with is that that's just one of the things that we do.
Yeah.
There's other stuff, right? So there's job handling when you want to process that geospatial data, and the OGC spec doesn't necessarily handle that because that isn't geospatial. And so they start trying to stitch together larger ecosystems with those APIs, and only one piece of it is that spec. The same thing goes for Stack and everything else. So we're currently evaluating like this larger ecosystem that GraphQL can represent that data, but it is not the spec. So it allows the specific details of a particular API to hold the spec. It actually makes it much easier because you can do CodeGen, you can do other things, so there database spec to generate the GraphQL schemas and stuff from.
Yeah, I would add to that that like, as you know, JSON schema, for example, is way more specific than GraphQL schema. What we do is that we try to represent all kinds of rules. That my guess is that particular protocols for particular types of data basically add specificities on a specific data. So it's not that you wouldn't want to, you still need filtering and pagination and all those things, and you would like to possibly query and choose specific fields, but you want extra specificity. What we do in our case in JSON schema is we generate directives that then we translate it to specific rules. So my guess is that there will be, in the future, more and more GraphQL variants. It could be on scalars, it could be like on directives that will take domain-specific data specificities into GraphQL. But I will look at this specific protocol, and it will be a nice exercise. Yeah. Yeah. Cool. So I think we're out of time, and there's a lot of other things here. This talk was more like an exercise of like rethinking those things. I'm not going to say what the right answer is, but I'll just say that like it will be cool if anyone here has an idea of where you wouldn't want to use GraphQL, talk to me. Because I'm looking for those things, and GraphQL is an evolving ecosystem and an evolving standards. And I do think it has a lot of benefits, like I mentioned, on service-to-service communication and many other things here that I haven't got to. That I think that my message here is like, don't tell anyone to tell you don't do this. Try it, and if it fails, let me know. That's my short message for today. Yeah, we're short in time, but that's it. You can come argue with me on our booth downstairs. I would love to have these discussions with all of you. Thank you.